Our question is array elimination. You are given an array and you have to select all possible cases such that for a particular case, by applying some operation, you can make all elements of array equal to 0 and using a finite number of operations. And if all elements of array equal to 0, that means that chosen k is your answer. Now we will see what is these three operations and what we can find or conclude from these operations. Now let's say, so first operation is select k distinct element in an array and find x, that is AND operation of all the selected element, and change all the selected element by element minus x. Okay, so the one thing here is, if you see these two parts, you will see, let's say there are n numbers in our array. The first number, second number, third number, fourth number. Here n equal to 4. And let's say there, of course, there are 32 bit for each integers, like this is like this. Okay, like this. Not say there are 30, let's say 31 bit from 0th bit to 30th bit. Fine. It's not like you have restriction on operations, you can do any number of times. Now let's try to make and you have to select k elements. So here k does not matter, means here only thing that matter is, can you make let's forget about k, can you make this 0 to 1? Focus only on these bits. Can you make this 0 to 1 by applying these operations? The answer is no. Why? To make this 0 to 1, you have to, how can you change this element, this bit minus something, either 0 or 1. Okay, and if you are selecting these elements in your k elements, then the AND operation would be 0, not 1. Like here is 1. And if you are trying to select these two integers a1 and a2, then for this particular bit AND would be 0, not 1. And if this is 0, then 0 minus 0 is 0 and 1 minus 0 is 1. So if you have a particular 0, then you can't change it to 1. Okay, and one more thing, there is no meaning to choose such a number that has bit 0. What I am saying, let's understand here. First observation, we can't make we can't convert 0 to 1. We can't convert 0 to 1. And now here is 1. Okay, not, let's say here is 1. Let's say for k equal to 2, we want to check. For the only thing here matter is, let's say we want to find answer for this. Basically, we have to convert all these bits into all zeros. Okay, like this. That means all the ones we have to change it to 0. Now see, can we change this all bit to 0 or not for k equal to 2? So we have to select two different elements. Now let's select these two elements. Let's say there are one more integer a3 like this, and can you make these two to 0? Let's see, you select these two integers and forget about other bits. Okay, now only focus on these bits. The AND of these two, k equal to 2, so you have to select two integers. So we select a1 and a2. For a1 and a2, we are saying 0th bit. For 0th bit, AND of these are 1, and 1 minus 1 is 0, so it becomes 0. 1 minus 1 is 0. Yeah, you can do. So you can do that. Now Now let's see for this bit. Now let's see for this bit, that is this one. Okay, so we have made this 0 to 0, and you can say that you are only focused on this particular bit. What about if you are applying these operations sometimes on this particular bit? What if these changes, if this changes, this is good for us. Why? Because first of all, you here 0 can't convert to 1. The only thing here will happen if only 1 is converted to 0 here. If we are focusing on or applying on some operations at this index, then if these are changing, then it will good for us. Why? Because here 0 can't convert to 1, as we can see here. Only thing that will happen is either elements or bit will be same, or it will convert to 0, 1 to 0. So it will good for us. Now one more thing, that can you, for k equal to 2, can you change all the ones for this bit to 1 to 0? Like there are only 1 ones here, can you change it to 0? Answer is no. Why? I told you that I am considering this bit, this particular ith bit, and for that you select any two numbers out of n numbers. You select any two numbers, you can't change because there is only one. Let's say you select 2 and 3. So for this bit, the and operation will be 0. You select a2 and a3 elements. As k equal to 2, you can select only 2 elements. So the and of these two would be 0, and 0 minus 0 is, it will replace by 0. 1 minus 0 is 1. So if you want to change for ith bit, then you can't select any number such that those have 0 bit, because it is meaningless. That number will be become same. So only you can select is 1. If let's say here instead of 0 there are one more 1, and here is also 1. Now see, you can select these two numbers and make them 0. Okay, how? Because AND operation of 1 and 1 will be 1, and 1 minus 1 and 1 minus 1 will be 0. Now again you can't convert this one to 0. Why? Because there is no one further, there is no other one, so definitely you need 2 1. So can I say, if for a particular k, any bit we found that is the count of 1 here is not divisible by k, then this k is not our answer. First observation, we see that we can't convert 0 to 1. Why? Because if we select this 0 and this 1, then the AND will be 1, 0. And if this is 0, then these two elements will be same. So whatever happen, you can't convert this 0 to 1. You can only convert 1 to 0. That's why we are focusing on each bit one by one for all elements. And second observation, you can only make changes from 1 to 0, and that will only happen if all the elements are 0, all the elements are 1 at particular that bit. Like for ith bit, if I want to make changes for this bit, then at least there should be k, exactly k element must be there, so we can make pair. Like here is 1, like for a particular ith bit, and there are first element, second, third, fourth, fifth, sixth element, and 1 2 3 0. Like if bits are like this for the ith bit, then if k equal to 2, then we can select these two elements and make this to 0. We can select this and this element and make this 0. But what about, there is only one left? What about this? No, there is no such pair. If you try to choose two elements like this and any one, then the result will be same for this bit. So whatever you do, you can't make change this. So the key observation is, if for any bit for a particular k, we will say all the k, and for a particular k, if we found any bit such that count of 1 is not divisible by k, that means we can't make k pairs such k pairs and we can't change. And one more thing, if we are focusing or on ith bit, then these things will also be changed from left or right. And if it is changing, then it is good for us. Why? Because no one, any 0 can't convert to 1. Only thing that will happen is 1 is converting to 0. That is good for us. Okay, so now let's see code here. Sorry, 1 second. Now we will see code here. Now let's see here. See, first of all, we are taking a input array, and after that we are counting set bit for ith bit. Like for ith bit, we are traversing all the elements and seeing that ith bit is set or not. If ith bit is set, then increase that count I plus plus. Okay, and after that we are applying these operations for each k. Like for k equal to 1 to n, we are checking k equal to 1 is possible or not. First we assume that it is possible, and if we see for any bit, if say number of ones is not divisible by particular k, then we will break from here and say that k is not our answer. And if this flag did not change, that means we got our answer and we print it out. Okay,